Hello everyone, I hope you all are doing very well. Thank you so much for joining us here in Study Room. Today we'll be learning chapter 1 of science that deals with chemistry. The name of the chapter is Matter in Our Surroundings. In this chapter, we'll be learning about what is matter and how can we distinguish between matter and non-matter. Furthermore, we will also be learning some properties of matter. Now matter has two kinds of properties, physical properties and chemical properties. In this particular chapter, we'll be learning about the physical properties of matter. So let's have a look at the chapter. First, we will learn what is matter, how do we define matter and how do we designate that, this is matter and this is non-matter. So everything in this universe is made up of material which scientists have named matter. Everything surrounding us, that is the air we breathe, the food we eat, stones, clouds, stars, plants, animals, even a small droplet of water or a particle of sand. Everything is matter. But there are two very specific qualities that define what a matter is. And these qualities are that matter is anything that has mass and that occupies space. So, we can measure mass and we can also measure space. We can measure mass by a unit that is known as kilogram. The SI unit of mass is kilogram. And we can measure space by determining the volume of the particular thing. Okay, so we can measure space by determining its volume. And the SI unit of volume means the measurement through which the standard through which we can measure a volume is cubic meter. So anything that has mass and that occupies space, that has some mass and that covers a particular area, that has some volume in it, is known as matter. Early Indian philosophers classified matter in the form of 5 basic elements, and they called these 5 basic elements as the Panch Tattva. These are air, earth, fire, sky and water. All of these, if you will notice, they have mass and they occupy space. They have a certain volume and therefore they are matter. Let's do some brainstorming. Which one are matter? Jeep, anger, sandcastle and your dreams. So Jeep is a very, definite object. It definitely has mass and it definitely has space. It does occupy space. It is a car, right? It's a kind of a car. So Jeep is a matter. What about anger? Now, anger is an emotion we feel when we are unpleasant with ourselves or with our friends or with someone else, So anger is an emotion. It is an abstract quality. It does take up space in our mind, but it does not have, concrete mass. It cannot be measured by kilograms and its volume cannot be measured. So we cannot call anger as matter. Now what about sandcastle? Sandcastle is made up of sand, right? Particles of sand. So a lot of particles of sand come together. When you shape them, you give them the shape of a castle. A sandcastle is there. So it does have mass, yes, and it does have space. It does have volume. So yes, a sandcastle is matter. But what about your dreams? Dreams are sort of visions, right, that you have during your sleep. But although they do take up space in your mind, but you cannot measure them, right? There is no fixed standard, no fixed quantity through which you can measure your dreams. So dreams, they are not matter. Let's learn about the properties of matter. The first property that we're going to learn is whether matter is continuous in nature or not. For this, we will be performing a very simple experiment. Take a 100 milliliter beaker, fill half the beaker with water and mark the level of water. Dissolve some salt or sugar with the help of a glass rod. Now in this experiment, we have taken a beaker of water and we have dissolved some salt or some sugar granules that is easily available in your home. And we have dissolve this with the help of a rod. So we have stirred the salt with the sugar granules in the beaker with the help of a rod. Now what do we observe? We observe that after the salt or the sugar is dissolved, they are nowhere to be seen. The only thing that is visible to a naked eye is water. It's a solution of water that contains salt or sugar and that is mixed in it. Moreover, we notice that the level of water has not raised. That means the level of water that we had earlier is the same level that we get after. Okay, so we conclude that there is no change in the level of water, and we conclude that when we dissolve salt or sugar in water, the particles of sand or sugar get into spaces between the particles of matter. water. So we conclude that matter is made up of particles. Let's go again to this diagram. What we observe is that water has particles, okay? And we are concluding that since the salt or sugar is not visible to a naked eye and nor has the level of water risen, so these particles of salt or sugar, these granules, they must have gotten in between the particles of water. So if this is water and if this is your salt or your sugar, okay, so these particles of salt or sugar must have gotten in between the water molecules, the water particles, okay, and therefore we can conclude that matter is made up of particles. Let's learn another property of matter. How small are these particles of matter? Now that we have learned that matter is made up of particles, let's learn how small are these particles of matter. For this, let us perform another experiment. Let us take 2-3 crystals of potassium permanganate and dissolve them in 100 milliliter of water. Take out approximately 10 milliliter of this solution and put it into 90 milliliter of clear water. Take out 10 milliliter again and put it into another 90 milliliter of clear water. Keep on diluting the solution like this 5 to 8 times. Now this must seem complex, but let me make it simple for you. So in this experiment, initially we have taken 100 milliliter of clear water. Okay, we have taken it in a beaker and we have added 2 to 3 crystals of potassium permanganate to this 100 milliliter of water. We notice immediately that the solution of clear blue water has changed and a pinkish hue is visible. Okay, so now this pinkish hue is because of the dissolved potassium permanganate into the solution of water. Now from this solution we have taken 10 milliliter and we have added this 10 milliliter of potassium permanganate to 90 milliliter of clear water, clear blue water that we had taken earlier. Again, we have extracted 10 milliliter from this and we have again added this 10 milliliter to 90 milliliter of clear blue water. What do we observe? We observe that each time that we are extracting 10 milliliter and adding it into a 90 milliliters of clear water, we are getting a potassium permanganate solution. Yes, but the color of the pink potassium permanganate is decreasing. The pink color is decreasing and in the end, we do get a slightly faded pink color solution, but the color has definitely most obviously been faded, and what we get is, the property, the length of the water is the same, the level has not risen. So what we can conclude? We can conclude that with every dilution, though the color becomes light, it is still visible. There must be millions of tiny particles in just one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. Hence, the particles of matter are very small. This means that each time that we extracted 10 milliliter from a particular solution and added it to 10 milliliter of clear water, the pinkish hue was there, but it has become very faded, right? But since it's still visible to the naked eye, so there must be some potassium permanganate added into it, right? From this we can conclude that the particles of potassium permanganate into 2 to 3 crystals, they must be so very small that even after diluting it 3 to 4 times, we are still getting that faded hue. This means that they must be very small, and they are so small that they are beyond our imagination. Now let's learn about the characteristics of particles of matter. Since we know now that matter is made of particles and these particles are very, very small and they're in huge amount, so let us learn what characteristics do they perform. Characteristics of particles of matter are that they have space between them, particles of matter are moving continuously, and particles of matter attract each other. And the particles of matter have space between them. This we have seen in the early experiment, in the salt and sugar experiment, right? Since we had added salt or sugar to the water particles and they had assimilated in between the particles of water, so we can conclude, yes, that particles of matter have space between them. Now particles of matter are moving continuously and particles of matter attract each other. Now let us learn more about these characteristics ahead. Now particles of matter have space between them. Let's look at another example to again ascertain this particular characteristic. When we make tea, coffee or lemonade, that is your basic nimbu pani, particles of one type of matter get into the spaces between particles of the other. This shows that there is enough space between particles of matter, and this space is known as interatomic or intermolecular space. This means that in the early experiment when we had sugar and salt, so the particles of water in between these particles of matter, sugar and salt particles were collected, or they got in between these particles of water, right? So this particular space is the interatomic or intermolecular space. Now, we know that this matter exists in three states: solid, liquid and gas. The three states of matter are solid, liquid and gas. Now, the arrangement of particles in these three states, they vary. The particles of matter in solid, they are very tightly wounded, they are very tightly packed. They do not have much interatomic spaces or intermolecular spaces between them. In liquid, there is a comparatively, more space. That is why the sugar or salt granules, they get easily dissolved. While in gas, there appears to be a lot of space between particles of matter, right? So you can see this in this small bubble, diagram bubble as well. Another thing to notice, and this is very crucial, is that when the temperature is increased, the particles of matter, they spread out, okay? So they scatter, and because they scatter, their interatomic and their intermolecular space also increases. Now this does not happen to every matter, but mostly, this is a very simple experiment. We have taken ice, like in this small diagram on the left hand side, you can say that ice exists in the solid state, so it has tightly wounded particles. Now when we increase the temperature, this ice changes into liquid, and when on increasing the temperature furthermore, this liquid changes into gas. So you can see in the diagram bubble that the particles of matter, the spaces, the intermolecular spaces, they are increasing with the increase of temperature. Now, let's perform a very fun activity. Are particles of matter continuously moving? This is the second characteristic, if you may remember. Take two glasses or beakers filled with water. Put a drop of blue or red ink slowly and carefully along the sides of the first beaker and honey in the same way in the second beaker. Leave them undisturbed in your house or in a corner of the class. Now we have taken two glasses. In the first glass, we have added red or blue ink slowly. And in the other one, we have taken, let's say, a tablespoon of honey. And we have dissolved them. We have, made it a stir in the glass, and we have, left them undisturbed in a small corner of the room or in your class or wherever you may find some space. Now what do we observe? We observe that the blue or red ink will spread out in water evenly within few minutes so that the water becomes blue or red in color, while honey takes some hours to spread completely. So even if you stir it or even you do not stir it, the main observation that we notice is that the blue or the red color in the first glass, it spreads out more evenly and, in a very quick manner, whereas honey, it takes some time, but it also does spread out. So even if you are not stirring it with a rod or with a spoon or anything else, even if you're just leaving it undisturbed in one corner, we do notice that these particles of matter, they intermix on their own. The very important characteristic to remember here is that they intermix on their own with each other, and they do so by getting into the spaces between the particles. So they do so by that same observation that we had noticed in the salt and sugar, or the salt and water, or the sugar and salt experiment. The particles of matter are continuously moving. That is why they get intermixed on their own, and they do so because they possess an energy which we call the kinetic energy. So what is happening, that the particles of matter, they intermix on their own, but why are they doing so? They're doing so because they have some particular amount of energy in between them, and even if you leave them undisturbed, two types of matter, the particles between two different matter, they intermix on their own with the help of this kinetic energy that they have. So they are in a constant state of bombardment, and they're in a constant state of continuous movement. Let's look at another activity, and this is with an incense stick or an agarbatti. Put an unlit incense stick in a corner of your class. How close do you have to go near it so as to get its smell? Now light the incense stick. What happens? Do you get the smell sitting at a distance? So first you have to take an unlit incense stick and you have to put it in the corner of the class. Now you have to come very close to the incense stick in order to smell it, right? But if you light it, what do you observe now? Even if you are towards the other corner of the room, you can still get the smell, you can still get the aroma, right? So we observe that when incense stick is unlit, we have to go more close, but after we light it, we can smell it sitting at a distance. This is another way that we ascertain that particles of matter are continuously moving and gases show diffusion property. How? Because the particles of the incense stick, they when they have when they have been lit, they go into the air. So like they intermix with the particles of air. Okay, so they are continuously intermixing with the particles of air, and that is why, because air moves faster, right? So that is why it travels with air even when you're sitting to the other corner of the room. Now, what is diffusion? Particles of matter intermix on their own with each other. They do so by getting into the spaces between the particles. This intermixing of particles of two different types of matter on their own is called diffusion. Now we have earlier observed that two types of matter, the particles in the two types of matter, they intermix on their own. But this particular process of intermixing, even if you give it an external stir, or even if you don't give it an external stir, that is with the beaker of water and the honey, or the beaker of water and the ink experiment. So even if you don't give it a stir, the particles of matter, they intermix on their own. And this intermixing, this process of intermixing, there is a name for this process, and this is diffusion. Question: why does diffusion happen? So I think I have already answered this before, but to make it very clear, diffusion happens because particles of matter, they intermix on their own. Even when given an external force, as in the sugar and the water experiment where you had stirred the sugar into the beaker of water, or even if you don't give it an external force, a stir, like in the water and the ink experiment, the particles of matter, they do intermix on their own, and that is how diffusion happens. The third characteristic of particles of matter was that particles of matter attract each other. Now let's demonstrate this with an experiment. Take some water in a container. Try cutting the surface of water with your fingers. We are unable to cut the water surface. We conclude that particles of matter have force acting between them. This force keeps the particles together, and the strength of this force of attraction varies from one kind of matter to another. And this force of attraction is known as interatomic or intermolecular force of attraction. So, solid, liquid, gas, all three states of matter, the particles of matter, they have some sort of attraction going on between each other. If you may remember, now solid has very tightly wounded particles, okay, and liquid they have comparatively more space between them, whereas gases, they have a lot of space between the respective particles. From this, we can ascertain that the interatomic or the intermolecular force of attraction, that means the force that keeps the two particles of matter, together with each other, right? So the interatomic and the intermolecular force of attraction in a solid is very high, okay? Whereas the interatomic or the intermolecular force of attraction in a liquid is comparatively low, okay? Whereas the interatomic and the intermolecular force of attraction is the weakest in gas. So this is how you know that what is holding the different particles of matter together. Now let's move on ahead. There is a brainstorming question. Take an iron nail, a piece of chalk, and a rubber band. Try breaking them by hammering, cutting, or stretching. In which of the above three substances do you think the particles are held together with greater force? So in this brainstorming question, let's take an iron nail, which is a very solid piece of solid, a piece of chalk, and some rubber bands. Now, if you try breaking them by hammering, cutting, or stretching, you may notice that it is the most difficult to break. It's the most difficult to break the piece of iron. You physically cannot just break it by hammering, cutting, or stretching. But yes, you may stretch a rubber band, and yes, you may break a piece of chalk very easily, right? So all these three states, all of these are solid, but we notice that the intermolecular or the interatomic force of attraction between these three examples of solid, they are very different. That is why an iron nail is very, it's very difficult to break it by hammering, cutting, or stretching, whereas a rubber band, it is easier to do so. And whereas also the piece of chalk, it's very easy to do it. So this means that although all of these are solid, but the force of attraction between the particles of these three solids, they are very different. So not one solid would be similar to the other solid, right? Not all the liquids can have the same properties. Yes, they do have some basic common overarching properties. Okay, like all the solids, they do have more or less more attraction, interatomic attraction, than say a liquid or a gas, but not all the solids can have, the same category of attraction. There is a question: which of the following are matter? Air, chair, love, smell, hate, almonds, thought, cold, lemon water, smell of perfume. Now, chair, most definitely yes. Chair is matter. Air, definitely yes. Air is matter. Love, no. Why? Because again, love is an emotion which we feel. It cannot be measured. Its space cannot be measured. Its volume, its mass cannot be measured. So love is not a matter, whereas you can measure the mass, and you can also measure the space or the volume of a chair or even air. Now smell. Smell is basically what you sense. Smell, basically. It's not a state of matter. Okay, air is a state of matter. Smell of perfume. Now, perfume, you may say that perfume is matter, but smell of perfume, it's smell, right? It's what you sense through your sense organs, through your nose. Okay, so we cannot say exactly that smell. No, smell is not matter, but yes, perfume is definitely matter. Smell is not a matter. Hate is again an emotion which we feel. It cannot be measured, so hate is not matter. Almonds, yes, almonds are matter. There are almond is food that we eat, and yes, it does have mass and it does have space. It does have volume. Thought, no, thought is not matter, because thought is your thought, right? You get an idea, you maybe think, you overthink. Thought is an idea, is an expression. So thought is not matter. You cannot measure thought. Cold in something which we feel, again, through our senses, through our skin, right? We feel cold or we feel hot. So you cannot say that cold is matter. But yes, the cold air which moves, that which can cause us to feel cold, that air is most definitely water. And similarly, the hot air that moves, which causes us to feel all sultry and uneasy, that hot air is also matter. But cold is not matter, and similarly hot is also not matter. But lemon water, yes, we had seen earlier, lemon water is lemonade, nimu pani. You dissolve lemon into water, so it's basically the intermixing of one kind of matter into another. So yes, lemon water is matter. Another question: give reasons for the following observations. The smell of hot sizzling food reaches you several meters away, but to get the smell from cold food, you have to go close. Now remember that incense stick experiment, right? When you had unlit the stick, you had to come very close in order to smell it. But when you had, lit it, you can even smell it from the other corner of your room. You may have noticed that in order to, spread the aroma of the incense stick with the air surrounding it, you had to light it, you had to increase the temperature, right? Similarly, over here, you cannot smell cold food from a distance. Why? Because the air, the aroma surrounding that cold food is not so strong, is not so scattered away, that aroma, that can reach from one corner to the other. Okay. Whereas when you increase the temperature, when you heat that cold food, and when you make it come to a state of hot food, now the aroma surrounding that food has obviously been given more energy, given more kinetic energy, and as a result of the increase in that kinetic energy, the smell of the hot food, the aroma which get mixes with the air, the aroma is able to float very easily and even reach you several meters away. Another question, a diver is able to cut through water in a swimming pool. Which property of matter does this observation show? Now, this is a very tricky question. A diver is able to cut through water in a swimming pool. But you may remember that solid, they have very tightly, they are very tightly packed together, right? So they have few space, they have less space in between their particles, so they have less interatomic space, whereas water being a liquid, it has larger interatomic or intermolecular spaces. So a diver is able to cut through water. That is because water being a liquid, they have more space between the particles. Okay, water being a liquid, they have more space between the particles, and because of this large space, when a diver goes right through water, it is able to cut through water. Okay, because the diver, he or she is able to break that loose bond, that loose interatomic or intermolecular bond between in amongst the water. Another question, what are the characteristics of the particles of matter? So we do know that particles of matter, they attract each other. We do know that particles of matter, they have spaces between them. And we do know that particles of matter are continuously moving. They are in a constant state of movement owing to their kinetic energy.